Alrighty, I'm going to do a problem now, a forces problem, but it's going to be at an angle, and it's going to be something involving friction that is a little more complex than what we've done before. So today's problem is a dump truck slowly raises its bed to empty its load. When the bed is at an angle of 23.3 degrees, a crate on the bed begins to slide off. What is the coefficient of friction between the bed and the crate? Is it kinetic friction or is it static friction? This is a little intimidating for a problem. We're only given one piece of information. We're given the angle. So we've got to figure out a whole bunch of stuff with one piece of information. All right, we'll do it. Just follow the problem-solving process that we've laid out, and it will work. So trust me, following the problem-solving process will work. So step one, draw a picture. And with my beautiful picture stuff here, that's a dump truck. So then it shifts it to drop the load. And we know that the angle is 23.3 degrees. All right. That's our only known. Yay. Okay, so what is the coefficient of friction? That's our question. Again, coefficient of friction, not the frictional force. So the coefficient of friction is just a number with no unit, separate from the frictional force. There's our picture, step one. Step two, knowns and unknowns. Pretty easy in this case. Step three, pick the object of interest. Well, at 23.3 degrees, a crate slides off the bed of the truck. Okay, I don't know anything about the truck. I guess I'm going to pick the crate in this case, and let's see if that's going to work. I don't know the mass of the crate, but I'm going to see if choosing the crate's going to work. So I'm going to pick the crate as it's just about to slide off. So there's our object of interest. What's the force diagram going to look like? We have something at an angle, so I draw my little box at an angle to remind me that this crate is on an incline. Forces that act on it? Well, we've got our force of gravity, always straight down towards the center of the earth. So that's the easy one. What else do we have acting on it? Well, the bed of the truck is pushing upwards, supporting the crate. So we have a normal force in that direction. And I think we also must have a frictional force. We're asked about friction, so I'm guessing there's a frictional force. The crate's trying to slide down the bed, so friction is opposing the motion. Friction's going to be going backwards like this. Is there anything else? Imagine you're the crate. Is there anything else pushing on the crate or pulling on the crate? I don't think so. I think we've just got those three forces. So that's what we've got. Now, the next step is choose a coordinate system aligned with the acceleration. Which way is this thing accelerating? Go back to my original picture. The crate, as it goes down, wants to accelerate in that direction. It's not in a standard coordinate system. It's at an angle. So I'm going to choose an angled coordinate system for this one. Plus y like this, plus x like this. So I've got my coordinate system. I've got my force diagram. Next up, do the chart of the x and the y variables. X and y have three forces. All right, so I've got my normal force, and I've got my frictional force, and my weight force. Okay, three forces. We have to figure out, are they in the x direction or the y direction, or both? Sometimes we have both. Normal force. So this is my x direction, this is my y direction. So normal and y, they're matching up. My normal force is in the positive y direction entirely. Positive normal, there's no x component at all to that one. The frictional force, go in this direction, well look at that. That's all in the x direction, in the positive x direction. So I have a positive frictional force, nothing in the y direction. And then the tricky one. We always have the tricky one, which is the weight. If you drop your triangle, if you make a triangle dropping down from the normal, then this top angle is always the same as the angle of the incline. So we do know that. But how do we put it in here? Okay, Which one is the x component? So x is in this direction, so I want this piece. This is my x component, this is my y component. Is the x component going to be sine or cosine? Well, it's opposite the angle. So opposite the angle, that tells me it's the sine component. Is it positive or negative? Well, it's going left in this direction. So down and left, so I'm going to have a negative here. Negative mg sine of theta. So that's the x component, negative mg sine of theta. Now my y component, that's this one, it's going down, it's going to be a negative, and it's the adjacent to the angle, so mg cosine theta. Alright, so is that it? Yep, I've got all three forces. I figure out x component, y component, all of them. Are we balanced or unbalanced in each direction? Go back to the direction of the acceleration. The acceleration is all this way along the incline, so it's all in the x direction. So in my x direction, my net force is going to equal ma. Because we have an acceleration, the net forces are not balanced. But in my y direction, there's no acceleration, there's no movement in the y direction even. So in the y direction, the net force is equal to may, but there's no acceleration. So the net force in the y direction, going to be 0. So the net forces here are unbalanced, the net forces here are balanced. We've got Newton's second law. Let's do it in the x direction, let's do it in the y direction, and that'll give us the two equations that we can use for this equation, for this problem. So net force in the x direction, add up all these forces, set them equal to mass times acceleration. Well, I've got nothing. I've got a positive friction and a negative mg sine theta equals max. So there's my equation using Newton's second law. There's my equation in the x direction. In the y direction, add up all the forces in the y direction, set them equal to, in this case, 0. I have a positive normal. I have a negative mg cosine theta. And that's it. So set them up equal to 0. All right. Now I have two equations that I can use. And those equations both come from Newton's second law for this situation. Go back to what I'm looking for. What am I looking for? Mu. Okay, this doesn't have mu, this doesn't have mu. What is the only equation I have with mu in it? Well, that's a fun equation. The frictional force equals mu times the normal force. So that's a third equation I have. All right. Now we plan our answer. And this is what I really recommend you do before you jump in and throw numbers into everything. Plan it out. Make sure you have enough information to do what you need to do. I want mu. So, mu. Well, F equals mu n means I need my F, my frictional force, and I need my normal force. I see that this, well, I might be able to figure out part of the normal force with this equation. So the normal force, if I just pop this to the other side, equals mg cosine theta. I'm a little hesitant because I don't know the mass of this thing. I do know gravity, I do know my angle. Let's just keep moving and see if we can make it work. Often if we're not given the mass in a problem, it means it doesn't matter. It will cancel out. So my normal force, I can figure it out, except that mass thing. Frictional force. Okay, here's a formula for the frictional force. So frictional force, let's pop this to the other side, is mass times acceleration plus an mg sine theta. Okay, I know my theta, I know g. Same issue with the mass. Same issue with mass. What's the acceleration in this case? So that's a subtle point in this problem. The question asked, what is the coefficient of friction between the bed and the crate that's sliding down? And is it kinetic or static? Remember, we have two types of friction. Kinetic friction is when something's already sliding, the two objects are moving with respect to each other. Static friction is when we have an object that's not moving with respect to the other surface. Well, if we weren't moving until we just get to 23.3 degrees, I'm going to argue that this is static friction. I think we have static friction. So I'm going to make that note right here. I think we're talking about mu static, not mu kinetic. Still doesn't answer this question. I know that, I know that. Not sure about mass, not sure about mass. And I don't know my acceleration. Well, if it goes up to 23.3 degrees before it starts moving, there is no acceleration from 0 degrees up to 23.3. So I can kind of figure that my acceleration is 0 up to that point. I'm going to say that AX is 0 until it starts moving. So this is a really subtle point about friction. So really my angle is 23.299999 to get acceleration equals 0. But I think this is going to work. Let's give it a try. So if my acceleration in the x direction is 0, well, this term drops out. So my friction is mg sine theta. Okay, there's a term for friction. There's a term for normal. And I'm looking for mu. Well, accepting this mass thing, I think I've got it. So can I make it work? Is the mass going to cancel out? Let's give it a try. So I'm going to set these two into the fun equation and see what we end up with. Can we solve for the coefficient of friction? Coefficient of friction. So if I rewrite this, bring the normal force, divide both sides by the normal force, it's going to be friction over the normal force. All right, so then I've got an equation for the friction force, an equation for the normal force. So this is going to go into the top, and this is going into the bottom. So my friction force, mg sine theta, over my normal force, mg cosine theta. And looky there, I have something with a mass on top, mass on bottom. Gone, gone. Masses did cancel. Good, because I didn't know the mass. And most force problems, if you're not given the mass, at some point in the process, your mass is going to cancel. You're going to have a mass in every term, and you can cancel it out. I also notice here, there's a gravity on top, there's a gravity on bottom. Ta-da! So we can get rid of it. This leaves me with mu is the sine of theta over the cosine theta. You could solve it like that, but I look at that and I say, hey, sine over cosine, that sounds familiar. I think I remember that the sine over the cosine is the tangent of theta. So I have an equation for mu. Look at that, how easy that was. Isn't that remarkable? All of that work comes down to this simple equation. So I know my theta, I can solve for mu. So mu is going to be the tangent of 23.3 degrees, which ends up being 0.43. And the tangent has no unit, so that has no unit, which is correct. The coefficient of friction is a unitless number. Is it reasonable? Well, we know that the coefficient of friction should be between 0 and 1, so yeah, that looks reasonable. Did we answer the question? We were looking for the coefficient, we figured out a coefficient, and I think we got this one done. All right, good job.